Here we go. Did YouTube catch that? Probably not. Um, what were we looking at? Quick review for those of you that were away. Don't try and write all this down. We said when you have what we called many body problems, objects attached by strings, the solution was treat it like one big Ubermass. Do a free body diagram or label the diagram if they gave you one, and then write an equation along the rope. So it became winner minus loser, and the only tweak we had to do equals m all of them times a. What do I mean by all of them? When you divided by m all to get the a by itself, it was m all. Add them together. We said you could also find tension. In fact, the phrase that I kept saying was to find the acceleration of everything, you write an equation for everything. To find an individual force, you write an equation for an individual mass. That was kind of our thinking. Okay? You want to find the acceleration of everything, your equation should include everything. You want to find something individual, pick an individual mass. And we looked at hanging masses, and I left off right here. I like example 4. I like example 4. Example 4 is a nice question. And we're about to enter a pretty multi-step question. We're finally going to get to a 5 or 6 step question here. But if we don't panic, we can handle this as long as we go step by step. I would not encourage taking shortcuts on this at this stage. Pause for a second. The nice thing is here, Ben, I have trouble calling these harder. They're longer, but if you go systematic, it's not going to be too bad. Even you can handle this. So, Ben, you and I are going to do this. We have a hanging mass. First thing I'm going to argue is, look, there's no way this is going to, don't write this down, spontaneously start accelerating that way. There's no way a box suddenly starts crawling on its own, lifting another box up. What I need to realize is if this is going to accelerate at all, it's going to accelerate right and down. Okay? And so I'll even go like this. I'll put a little arrow. That's the acceleration. What's part A, Ben, asking me to find? You know what this is a good job for? And I'm going to work from left to right. So I'm going to start with the 3.2. What are the forces acting on the 3.2? Get the obvious one. I'll call it M1G because there's more than one mass. I'll call the next mass M2. Is it sinking into the ground? Is it flying? Which one is next? I'm going to have a normal force number 1 to go with mass number 1. Yes? Is the rope touching it? So what do we call the force from the rope? You're feeling some right now. Is there friction between this mass and the table that it's sitting on? How do you know? Because they gave me a coefficient of friction. That's usually a hint. They want me to include it. Which way is this mass going to slide? Which way will friction be pointing? Yeah. And I'm going to call it friction force 1 to go with mass number 1, just to be lazy but organized. Let's walk over to the 2.8 kilogram mass. What are the forces acting on it? Get the obvious one. Is there more than one mass? I'm going to call this M2G. Is it sitting on a surface or is it dangling in midair? So no normal force. Don't get normal force loopy and start putting it in everywhere. Ah, rope is touching it. In fact, tension is slowing this mass down. Okay. Who's winning? What's causing this whole thing to accelerate? Gravity pulling on the hanging mass. So what I'm going to do is I'm going to walk along the rope, and the pulley causes the rope to change direction. That's fine. All a pulley does is it causes force to change direction. That's not a problem. Any forces that once they end up down here end up pointing down, I'm going to call winner plus. Any that once they get down here end up pointing up, I'll call loser minus. So let's walk along the rope. Here we go. Who's winning? Yep. Now I run into this tension. This tension here, winner or loser? Oh, now I run into this tension. This tension here, winner or loser? Yep. Now I run into this friction, winner or loser? What about M1G? Is it along the rope? Then I'm ignoring it. I'm writing an equation for the rope. Have I reached the end of the rope? Yeah. Equals. Do I have forces from more than one mass on the left? Then I better have more than one mass on the right. M all A. Ben, how was your weekend? Put your pencil down. Come on, lose some tension with me. Stretch it out. Oh, yeah. Isn't that great? Why are these equations so relaxing? Because we always lose a little tension. Right? Minus t plus t, they cancel out. What are they asking me to find? So I'm going to get the a by itself. How? Okay. I would have no problem, this would be an advanced question, giving you the acceleration and asking you to find the coefficient of friction, which is hidden in there. Then you would get friction by itself, and you'd end up dividing by the normal force. Very doable still. A couple extra steps. There's going to be, I think, some in the homework or else next lesson. Okay? Yeah, let's use Trayson's theorem. So I'm going to go, and mass all is really just m1 plus m2. Okay. A equals m2g minus, what can I write instead of friction, force number one? Friction is what times what? I can go mu times normal force number one all over m1 plus m2. Ben, is the normal force in this question a weird, tricky one? Is there an extra vertical force acting on mass one? Are there arrows pointing up or down on mass one? No. I don't know the normal force. Oh, but look. I think I can use my shortcut. How big is the normal force? The same size as exactly. So I will allow you to go boom M1G. I do want you to show me the normal force so that you know, no, friction is not mu mg, and I'll never say that. It's mu times the normal force, and I've got to figure it out. And for easier ones, yay, it's mg, but we've done some with extra vertical arrows where it was not. A bunch of those on the last lesson. Okay, I'm going to stick in numbers. I've scrolled down. What was M2, Ben? G, 9.8. Minus, what's mu? I don't know. What's mu with you? M1. M2. No, G, sorry, G, 9.8. And then it's going to be over 3.2 plus 2.8. Is that right? All of you want to try typing this into your calculator because this is a pretty complex looking fraction. If you have the fraction button, you want to use it. Those of us that don't have the fraction button, definitely brackets around the top and brackets around the bottom. Grayson, do you have the fraction button? Good for you. Juno, you have the fraction button? Oh, good for you. I don't. 2.8 times 9.8 minus 0.12 times 3.2 times 9.8. Yep. Close off the top, divided by, open up the bottom, 3.2 plus 2.8. Now, I did tell you, I don't know if you remember, Ben, last day, there's a bit of a built-in error check. If I cut this rope and this object is in free fall, what's the biggest the acceleration can be if we're on the Earth? I know it's going to be less than 9.8 because the 3.2 is slowing it down. So if you get an answer bigger than 9.8, you've definitely made a typo. I got get 3.946133333. I'll go 3.9 what? 5 will round off properly. That was, and I should have put a little part A right here. That was part A. Megan, what does part B want me to do? We can use, oh, you're having a typo? That's, no, I read your body language. Got it now? Okay. What does it want us to find? We can use either mass. Which mass looks uglier, like it's more cluttered? be kind of obvious. I think I'm going to use the 2.8. Okay. It's less cluttered. Which way is the 2.8 accelerating, up or down? Which way is the winning direction? Same answer. Which way is the winning force going to point? Same answer. Okay, so I'm going to use the 2.8. Looking only at the 2.8, who's winning? Okay, so when I say looking only at the 2.8, what I'm saying is this doesn't exist anymore. There is no 2.8. I want the force on my free body diagram. Who's winning? Good. Who's losing? Good. Stop. We're only doing the force for that. To find an individual force, we're going to look at an individual mass. So it's going to look like this. M2G minus tension equals M2A, not M all A, because I'm just writing an equation for M2, and I picked M2 because it was less cluttered. What are we trying to find for part B? Oh, how would I get the T by itself? What's right in front of it that I don't like? Swappy dance time. Plus that, minus that. I'll get tension equals M2G minus M2A. Is that correct? I've scrolled down. What was M2? 2 point something? 2.8. G was 9.8 minus 2.8. And I'm just going to stick my answer button for the acceleration right there since it's sitting on my calculator. What do you get? 16.3908, 16 point, I think 4, if I round off properly. Yes. And it's a force. What are the units, Megan? Newtons. Yep. Now, Tyler is going, Mr. Dueck, what if I wanted to use mass 1? We'll just write, for what it's worth, you would go like this. Which way is mass 1 accelerating? To the right. Who's winning? Tension minus friction 1. That equals M1A. That would be the equation just for that one. It's a little easier to get the T by itself because you only have to plus the friction over, but you got to do friction again. So I probably would have picked mass 2 as well because a lot of the math I'm doing in my head, I want something that's less cluttered. Okay? But you get the same answer no matter what. We can even handle more than 2 masses. Here's your 3 mass question. I'm not going to give you a 3 mass question on your test, maybe as a bonus, but not as an actual question. I might give you one. I should have caught that headphone from day one. Wow. I might give you one on your take-home quiz, just to let you know. And if you can handle 3 masses, you can handle 4 masses. You can handle 5 masses. You can handle as many as you want, but eventually you just, okay. We'll finish with this. Okay. Bishan, what does part A want me to find? This is a job for a free body diagram. Again, you don't have to. You can start in the middle. You can start on the right. Just so all of our equations look the same, though, Trayson, I tend to start on the left. So, Bishan, what are the forces on the 1 kilogram mass? Get the obvious one. Is there more than one mass in this question? Call it M1G. And, is there more than one rope in this question? I'm going to call this tension 1. I'll call the other rope tension 2. Or you could go tension L for left and tension R for right. I've told you from day one, Paul, lazy but organized. Be organized. I will get annoyed if kids write MG and don't write M1G because later on you'll get the M's confused. Any other forces acting on this guy? Is it sitting on a surface? That's it. The middle one is a bit trickier. What are the forces acting on it? Get the obvious one. M2G. And I think there's going to be a normal force the same size as mg. I'll call it normal force number 2 to go with mass number 2. What else? There is no F app. Which one? On the left or on the right? Yeah, okay. So here, this rope, I already called it tension 1. There's my forces come in pairs, Newton's third law. This rope, I'll call tension 2. Anything else? What have we missed? How do I know? Because they've got a coefficient of friction. They're saying there's some friction. Um, which way is this mass going to slide? To the left or to the right? How do you know? Okay, yeah, I have to expect you to have some basic understanding here. So yeah, it's going to accelerate in the direction of the heavier mass, if it accelerates at all. Now, if I get a negative answer, it might be friction is so big that this whole system ain't going anywhere. But we'll find out. So I'm going to point friction in the opposite direction of sliding, and I'll call it friction force number 2 to go with mass number 2. All right. What are the forces acting on the 8 kilogram mass? Get the obvious one. Which way? I'll call that M3G. What else? Tension what? Yep, because that's the second row. Any normal force? Are we sitting on a surface? No. Which way did you say this thing is, the middle mass is going to accelerate, Mission? You were correct. So what's causing this whole thing to accelerate? What's this chain reaction force being initiated by? Which one? Because there's 3 of them. Okay, I'm going to make a little note. I'm pretty sure A is in that direction. Again, I'm going to walk along the rope. Anything that ends up, Bella, you're going to make it. Anything that ends up pointing down once it gets here, I'm going to call winner plus. Anything that ends up pointing up once it gets here, loser minus. So let's walk along the rope. Winner, M3G. What about tension 2, this one here? Winner plus or loser minus? What about this tension 2? What about this tension 1? I should scroll up a tiny bit so you can see them all. What about friction force number 2? Yep. What about this tension 1? Now, here's where you got to be careful, because you might say, Mr. Dueck, tension 2 is pointing up. It was a loser. So tension 1 is pointing up. It's a loser. But if you follow it, follow it, follow it, follow it, follow it, when it gets to this side, it's pointing down. Similar with M1G, you might be tempted to say, well, M1G is pointing down, and we call down a winner. But again, if you follow M1G over the pulley and then down the pulley, when it gets to this side, which way is it pointing? Loser up. We've reached the end of the rope. What about M2G, Mr. Duke? Doesn't show up in my free body diagram because it's not along the rope. It's going to be M all A. Everybody, put your pencils down. Everybody stretch, because this is like a double release of tension. Look at this, because we're going to lose tension here and here. This is like a spa day. Oh, man. That's like aromatherapy and everything. So relaxing. What did A want me to find? So, yeah, in fact, I'm going to divide by M1 plus M2 plus M3. That's what M all means. Do you see what I meant earlier when I said I don't find these questions harder? They're longer. They're longer. Okay. A equals, let's jump on in. What was M3? I've scrolled down. G, 9.8, minus mu times the normal force, number 2. Oh, wait a minute. What can I write instead of the normal force, number 2? Which mg? M2g. Okay. And then minus M1. What was M1? G. And that's over, what was M1? 1 plus, what was M2? Plus, what was M3? Okay. Now, I don't want to rewrite this, so I'll show you something I'll also accept. Showing my work, but also being organized. What can I put instead of the mu? What was the number? What can I put instead of the M2? Yeah. What can I put instead of the 9 point, instead of the G, 9.8? If it's a lot of work, I might be tempted just to do that. That's organized and lazy, because now I can go to my calculator. Yeah, you want to practice typing this in, all of you? Tyler, you too? I got to put brackets around the top. 8 times 9.8 minus 0.25 times 9 times 9.8 minus 1 times 9.8. I got 2.586 and then the 1 repeats. Yeah. So 2.59 if I round off properly. Morgan, are we done? No, that's A. What does B want me to find? Ugh. Okay, you know what? I'm going to try and do this quickly. I'm going to do the tension on the left, on the left. I'm going to do the tension on the right, on the right. Morgan, this is maybe stupid obvious, but which mass am I not going to use to find the tensions? Which is the cluttered mass that I'm going to run away from? Yeah, don't be using M2. You can do it! I would not. So, M1, let's write an equation just for this. So again, you're imagining everything else is gone. Which way is M1 accelerating, up or down? Which way is the winning direction? Same answer. Which way is the bigger arrow? Same answer. Which force is winning then on M1? Which one? Which force is losing on M1? Which one? Okay, so next time you could have said, which force is winning? T1. Which force is losing? M1G. And we all know what we're talking about, right? Okay, so what's my equation? Equals what? M1A. Yes? Okay, don't go to your calculator yet. Hang on. What about on the right-hand side, Paul? Which way are we? So now we're going to use this mass. Which way are we accelerating? Who's winning? Who's losing? Equals M3A. We're going to cut corners. Half the class is going to do one of these. Half the class is going to do the other one. So M3G minus tension 2 equals M3A. Is that what you said? Okay. The right-hand side, get this T by itself and then solve using your answer button. The left-hand side, get T2 by itself, swappy dance, and then solve using the answer button. I'm going to do both here really, really quickly. Let's see if we all end up in the same place. We should get two different answers for tension because it's two different ropes. Left-hand side, is that what you got? 12.4? Yep. Right-hand side, 50, yeah, if you want the actual values, 12.3861 repeating and 57.71 repeating, I think, if you use your answer button for both of them. Yep. So can we handle three masses? Yeah, it's doable. What's your homework? Um, I'm gonna gamble because on your test, I'm not gonna give you one of these with no friction. I'm gonna skip 1 and 2. I'm gonna give you the tougher questions right away. Try 3. I didn't do one quite like this in your notes. See if you can figure it out. Your hint is there's going to be friction on both of these along with tensions and M1Gs. Do a good free body diagram and you'll be okay. Here's a 3 mass question. I'm going to skip that one. I am going to give you 5. Definitely going to give you 6. Put a star next to number 7. Okay. Part A isn't too bad. See if you can impress me with part B. Part B wants you to find the coefficient of friction of the 2 kilogram mass. It wants you to find how sticky it is between the 2 and the 12. See if you can figure it out. I'm not going to give you one quite this tricky on a test. This is me making the homework tougher. Ooh, here's a 3 mass question. I haven't done one like this in the notes. I'm going to see if you can figure this out. Colby, what's number 9 asking me to find? Get the mu by itself. So see if you can figure out how to do it. I deliberately didn't do one like that in the notes. And see if you can figure out how to do number 10 as well. I deliberately didn't do one like that in the notes. And then if you want to try, this is from an old Physics 12 scholarship exam. See if you can figure it out. It's actually all Physics 11. I'm not going to ask you one this tough, but if you're looking for a good challenge, see if you can figure it out. Okay? Class is yours, my angels.